Oh my god, I'm getting so bored. Do you guys want to do something?
Well, I wanted to play soccer outside, but it's raining, so.
But then how about we play inside?
You guys want to try something like inside soccer or something like that?
Yeah, we can do that.
Sure, let's give it a shot.
Okay, so for the game, you're gonna hit the soccer ball to the beach ball.
Oh, okay.
You missed.
Here, let me show you how a pro does it. So easy.
Show off. But I have a question. Why does the ball react in this way? I mean, the soccer ball is heavier than the beach ball, so shouldn't the beach ball go flying?
Well, obviously no, because momentum is conserved and the beach ball is going to act accordingly.
I'm still confused.
Alright, we'll show you.
Okay, so what's going on over here? Why do we have these place markers and stuff?
Okay, so basically what we're going to do is same thing as before. I kick the soccer ball and I try to hit this ball. But this time, since we have these place markers, we'll be able to measure distance and also keep track of time. With that, we'll find velocities, and we can use that in solving whether momentum is conserved or not.
Okay, makes sense. Let's give it a shot.
Alright, so what we'll do first is find the distance of the initial path taken.
Okay, let's measure the distance.
So that's about 185 centimeters.
So 1.85 meters?
Yeah. Alright, so you have the timer, right? Okay, so basically how we're going to keep track of time in this is that once I kick the ball, you press start, and once it collides with the second ball, you'll hit lap. That way we can have initial and final time of the paths taken, and when the ball comes to rest, that's when you press stop.
Got it.
Did you guys get it?
Yeah.
Yep.
Go.
Alright, so this is coming up to about 0.8 meters.
And I think that was 0.5 meters?
Exactly, so now that we got the distances covered, we should measure the masses of the two balls.
Okay.
Alright, so get the mass of the beach ball and then we'll get the mass of the soccer ball, and with that we'll find momentum.
The mass is about 0.250 kg.
Alright.
Okay, so just because I didn't have any proper thing to hold the ball with, so I guess we just gonna consider the duct tape or the scotch tape as negligible. And so this gives me the mass of about 0.8 kg.
So to find the initial momentum, we're going to use the values we just calculated. Our initial distance was 1.85 meters. The time it took was 3.30 seconds.
Okay.
And now we're going to use the equation delta d over t to find the velocity.
Okay.
That comes out to be 0.56 meters per second. For the beach ball, we know that it's rest, so the initial velocity is 0 meters per second. To find the momentum, we're going to use mass of the beach ball times velocity of the beach ball plus mass of the soccer ball times velocity of the soccer ball.
And shouldn't this be 0 because of that?
Yes, so
Okay.
that's going to come up to be 0. And then it's just 0.8 kg in times 0.56 meters per second, which will equal to 0.448 kg
Meters per
meters per second,
right?
which is going to be the momentum.
I see. And now we do the momentum for the second part?
Yes.
Okay.
Okay, so now that we've found initial momentum, we can go ahead and find final momentum. So unlike the last situation, this time the beach ball actually moves, so it has a velocity. So again, from the values measured, we can find their final velocities. The soccer ball had moved 0.8 meters and the beach ball had moved 0.5 meters, and both shared this path for 2 seconds. So the final velocity of the soccer ball is 0.4 meters per second, and the final velocity of the beach ball was 0.25 meters per second. So with their masses and now their final velocities, we can use the formula as we did in the initial momentum and find final momentum. So why don't you give that a try?
Yeah, sure.
As we solve initial momentum, we can solve final momentum. So the mass of this beach ball is 0.25 kg with its final velocity being 0.25 meters per second, and the soccer ball's mass being 0.8 kg and its final velocity being 0.4 meters per second. So with that, we come up with a final momentum of 0.3825 kilograms meters per second.
Oh yeah, they are pretty close.
Exactly. So here we can see that initial momentum and final momentum are conserved, and you can account for the differences due to...
Let me guess. Friction and air resistance?
Exactly.
Oh wow, I feel a little smart now.